Welcome to this video, and thank you for coming here. During the coming minutes, we will be working on a practical session dealing with intraspecific competition. Our objective here is to put into practice the knowledge that we already acquired during the theoretical sessions in our ecology lessons. And the teaching objective is that you improve your knowledge on geographical information systems, spatial analysis, and as well as dealing with databases. Our objective under a ecological point of view is to transfer the knowledge on ecological intraspecific competition to environmental management. And we will use a very interesting case study which is focused on a very special area, a protected area called Sierra Nevada, which is located in the southeastern part of Spain. A very important part of this area of Sierra Nevada is covered by pine plantations. This is a very particular forest type that was artificially created by people 60 years ago, more or less, and they planted all this forest in order to halt soil erosion. And they succeed with this process, but the problem nowadays is that all these pine plantations are very, very dense, and they are suffering a very intense process of intraspecific competition. So our objective is to work with this case study, and we will design a workflow, a methodological approach to decide where to do some managerial activities in these pine plantations in order to reduce the intraspecific competition, allowing the growth of natural vegetation beneath the trees. In order to do that, we will use a geographical information system and some other tools that we will study during the session. All the information that you need to accomplish this task is already uploaded to the Moodle, and part of that information is also available for free on the internet. And here is the section within the Moodle where we can find all the information. Let's have a look to this information, because it is in Spanish and maybe some of you cannot easily translate, cannot read Spanish. This first file is the guideline, is a dynamic guideline to do the practical session. Although it is in Spanish, you can easily translate all the information using Google Translator or any other software tool. This one is the same information, but in a PDF format. You can download that information. Of course, it's also very easy to do it. And the rest of the information is already linked here to these two documents. Let's click here, and we will see the guideline. The guideline is uploaded to my personal blog, so you can access this information even outside the blog of the University of Córdoba. This is the URL that you can use to connect to this guideline. And this very long document has several sections. Let's go for some of them step by step. First of all, there is a section dealing with our objectives and the ecological context of this case study. I'm not going to go to detail here. The study area again, and then this is one of the most important parts of this document is the workflow that we are going to follow. And you can see here a very tiny workflow. It is not possible to read it, but we have a zoom. If we click here and go and scroll down, you will see this zoom. We are going to zoom in, and then you can pan with your mouse, click and drag, and it's quite easy to draw it now and to find all the steps that we are going to follow to accomplish our objective. Another important point in this workflow is that some of the shapes that you can see here are linked to files that we will use during the execution of the practice. So you can click here and you will obtain information that you need eventually. I'm going to zoom in again. Well, then the next section in this document describes the variables that we're going to use to accomplish our task, to accomplish our objective. We already know that there are several environmental or ecological variables that determine the capability or the suitability of the landscape to support vegetation, and we will use only three of them. The first variable that we are going to use is the density of the pine plantation, and we know that the higher is the density, the more suitable is to receive these forest treatments, which are thinning. We want to thin, we want to clear cut the forest, some of them, it won't be a very intense clear cut. We only want to clear cut the part of the forest in order to reduce the intraspecific competition by pines. So the density of the pine will be the most important variables. The second one will be the distance between pine plantations to sources of natural vegetation. This means the distance between pine plantations and oak forests, which will be the most important vegetation type that will invite or will colonize the pine plantations once we thin them and once we clear cut them. So we will need to model this distance from pine plantations to sources of seeds. And the third one will be is going to be the capability of the soil to retain water. We will model this variable by using a digital elevation model, and we will consider that the more concave is a part of the landscape, the more suitable to store water in the soil. So we will use only a topographical surrogate of soil humidity. The next section is very important as well, and since it contains the data that we are going to use to accomplish this task. And we are going to download this information right now. The first data source is a vegetation map from our study area, and we will use this map to create the distance map from pine plantations to sources of seeds. And this link and goes to a video that shows how this map is structured. We are going to download this information right now by clicking here, and this zip file will be stored in a folder called Intraspecific Competition Practical Session. Okay, now I'm going to unzip this file, and I will obtain here it is. Here is the zip file, and here is a folder created once I unzip this one. And we are going to use these files as the vegetation map. It is a shape file. We will have a look to that in a minute. The next file is a map showing the density of pine plantations. expressed in percentage. I'm going to download that information as well. I'm going to put it in the same folder. And the third one is a map of wetness index, or potential wetness in the soil. I'm going to download it as well and save it to the same folder. And the last one is a raster map showing the distribution of pine plantations in Sierra Nevada. It's again another TIFF file, which I'm going to download here as well. Okay, we will open these files very soon. And the final section of this document is a step-by-step. These steps described here, those numbers, corresponds to the steps that I have written down here. So we will follow both threads. We will follow the written step-by-step as well as the graphical step-by-step. In order to do that, I'm going to open this workflow in another tab within my browser by clicking here. Okay, open with diagrams.net, but sorry, I'm going to open it in another folder, in another tab, by right-clicking here, and then I'm going to abrir enlace en una pestaña nueva. Okay, and then abrir with diagrams.net. I won't need this tab any longer. And here is the original version of the workflow. So what we are going to need now is this diagram showing the workflow as well as the step-by-step, which is here. Okay. Well, we will move from this tab to this one, and then we will have another software tool called QGIS, which is the Geographical Information System. Let's open the GIS here, and let's load here all the information that we are going to use. Let's load all this stuff. We go to layer, add vector layer, and then let's move to the folder where we have all this information. It's here. And here it is. We click on the file with the extension SHP, and then add and close. And here is our vegetation map. We can also add layer to the GIS by simply click and drag all this information. It's quite straightforward, and we can also do it at the same time with two layer by clicking Control on the second one. And well, this is all the information that we will need during our session. This first map is the tree cover density, expressed in percentage. Let's put some color to this map. Okay, I'm going to add some transparency because I'm going to deploy aerial orthophotography here. Here is my list of web map services. I'm going to load the most recent orthophotography. Here it is. It's coming now. It is connecting to the internet. Okay. And well, this is our tree cover density map. The green, the darker, the more dense. And another layer is the compound topographic index. I'm going to put some color as well I'm going to use this other ramp here, and I will use this quantile classification pattern, which is more it's more appropriate for this visualization. Okay. And we can see here that let's wait some seconds. The bigger, the higher this compound topographic index, the more convex is the area. This is a ridge, a summit. This is the summit of a hill, and this is a river, a creek. So this layer shows smaller values here in concave areas, and higher values here in convex areas. So we are going to assume that the higher the numbers here, the slower or lower capability of the soil to store water. And this layer is representing the distribution of pine plantations. So I'm going to leave it in black, just for us to know, in black color, just for us to know where our pine plantations are. This raster file contains only two values, one for pixels occupied by pine plantations, and no data for pixels occupied by any other vegetation type. Okay. And finally, this is our vegetation map, which is a vectorial map composed by some thousands of polygons. And as I already said, the structure of this vegetation map is described in a video that I already referred to. The interesting point here is that we are going to use only one field in this map, the field called let me find it. Sorry, it's not straightforward to figure out. We will use this one. The field called des UC 07. This field describes the vegetation, the vegetation type, or the land use type in 2007, and we are going to use this field during the workflow. Okay. Well, now we are ready to go for the first step in the workflow. The first step is to create a new field called this target in the attribute tables of the shapefile belonging to the vegetation map. This first step is also described here as create field discharge, and we are going to proceed like that. To do that in the GIS. In order to do that, we just have to open the attribute table of the shapefile. It takes a little bit because it has almost 30,000 polygons, and then we will open an editing session. And we will add a new field by clicking here, new field. The new field will be called this target, and it contains numbers, and the length will be just 2. This is the amount of numbers that we will be able to include in this field. And then we press OK, we click OK, and the system creates a new field at the end of the list of fields. Okay, here it is. It is already empty, and we will fill that. We will populate that field in the next step. We don't need to tackle the editing mode because we will do it. We will in the next step we'll need to keep this editing session open, but we will save the edits in order to keep our information safe. Let's go back to the workflow, and the next step is to select those polygons containing pines. We need to do that because the process or the algorithm that we will use to calculate the distance between pines and sources of natural vegetation needs a layer containing the polygons with pine and another layer containing the polygons with quercus, with oak forest. In order to do that, we will distinguish, we will add a sort of label to those polygons containing pines and another different label to the polygons containing quercus. Okay, so in order to do that, that is the reason why we have created that field. So we have created the field, and then we will select the polygons with pines, and we will add the number 1 to all the records corresponding to the polygons containing pines. Okay. So we are in the next step, number 2. If you click here, if we click here, we will obtain a text file containing the SQL the query sentence that we will need to inject to the GIS in order to select all those polygons. This same information is here, so we can also copy this information, and then we go to the GIS, and we can click here to select features using an expression. Select features by expression, and this is the editor of the expression. What we want is to select all those polygons that has a specific list of values in a specific field. So we need to go for the fields of our layer. This is the selected layer, and as I already said, we will work on a field called let me figure out where it is. Here it is. This UC 07. And once we click here, it is possible to select all the different values contained in that field, and we can build our query from here. For example, let's imagine that we want to select all the polygons containing in this field the value equal to formaciones arboladas densas coníferas. This is a very dense pine plantation. We click here, but we will also want to add to this selection all other vegetation types containing pines. So we need an operator called OR in order to select some other polygons. So now we will select polygons satisfying this query, or some others satisfying this other. For example, this one. Yes, it is just an example. Once I finish my query, I can click here, select features, and I will have a selection of all the polygons that satisfies the query. But if you remember, I already have a query in the clipboard, so I'm going to paste it here. But it is invalid, unfortunately, because some lines have been added. So I'm going to delete these lines here. Something is wrong. Expression is invalid. Maybe well, I'm sorry, I'm going back to this. I have copied this. I'm going to copy this one because it doesn't has some characters. It is still invalid. Let me have a look to this. I'm sorry for the problem. It's not easy for me to anyhow, the expression is invalid. Why? Something is wrong. I'm sorry. Let me figure out what's going on here. It should be working. Select values by expression. Okay. And this is the layer. Okay. I go to select the fields. Let's go for this one, for example. This is equal. And now the selection is valid. It's funny. Let's wait here now. Well, and now it works. I don't know what. Well, maybe the reason is that in my first attempt, the editing session here was opened, so and I have closed it now. Well, it is working now. This is the query that we need to run, and then once we have it, just click here to select features, and many polygons within our layer will be colored in yellow color, and all those polygons are qualifies as pine plantations. Okay, let's open the attribute table again. And let's go for let's go to until the end of the list. This is the field that we want to populate with the number 1 for those selected polygons. In order to put a number 1 in those polygons, we are going to click here. This is the field calculator, and it is quite easy. We are not going to create a new field. We will update an existing field, and we will update the field, the last one called this target, and in this part of the screen we are going to type the number 1, meaning that we will add number 1 to only this amount of selected polygons. And once now we are ready to click here, and the computer is now adding number 1 to all those polygons. And if we press this, if we scroll down, we will see some yellow polygons, not yellow, but blue polygons, and we can confirm, we can check that the system has added number 1 to all of them. Okay, let's toggle editing mode, and of course we will save the results. We don't need the table anymore. And then we are going to go. We will go to the next step. We have just done number 2. Let's go to number 3, and let's copy the query that we will to to execute. And let's go back to the GIS. And again, we press here, select features by expression, and some of the polygons are already selected, but the new selection will override the old one, so there's no need to unselect them. We paste here, and this selection, this list of different vegetation types contains all those vegetation types that can be considered as seed sources for our study. All those polygons will be providing seeds to the pine plantations in order to colonize them once we conduct the thinning process that we are going to suggest. Okay, so let's select the features, and we will have a different list, a different set of polygons. We can close here, and we repeat the same process. Go to the open attribute table, and we will calculate the field again by clicking here. Again, we are not going to create a new field, we are going to update one. Actually, we will update the last one, and we will add the number 2 to only the selected features. We click OK. And let's check that it is working. We have this number 1s corresponds to the pine plantations, and the number 2s correspond to the seed to the sources of seeds. Okay, and then the empty fields, empty records, are corresponding to other vegetation types that we are not interested in. Okay, we close the editing session again. Of course, we want to save the results, and we are now ready to go for the next step. The next step is the step number 4. This next step involves the rasterization of the already existing shape file, using the field this target as the field where the field used to create the raster. So we will have a new raster that will contain only 3 values. 1 for pine plantations, 2 for sources of seeds, and no data for the rest of vegetation types. Okay, this is the step number 4, and here you have the instructions to do that. Let's go to the GIS again, and a very important point is to remove this selection, to unselect all these polygons, because if we do not do that, the raster will be created only from these selected polygons. So we click here, and now the system will create a raster with all those polygons. Let's go to raster file, to raster menu, conversion, rasterize, vector to raster. The input layer is this one. The field that we will use to create the raster is this target. We will leave this field empty, and the output raster size units will be expressed in the georeference units, and the horizontal resolution will be 100 meter, and the vertical one 100 meter as well. The output extent, this is a very important selection, will be we will use a layer extent, and we will use any of these, but I'm going to select this one, pine plantations. Okay, pine plantations is our canvas, as to say. Our canvas, template, that's the word. This will be our template to select the extent. Okay, and I think that we are all set. We only need to rasterize. We only need to define the temporal file, the temporary file. Let me have a look to the name that we should add. The name is this target.tif. I'm going to copy that. Okay. But I need to click here to browse to the folder. My folder is this one, and now I'm going to save here this file. Oh, sorry, the clipboard. Okay, I need to remove this final dot, and we are all set. So we click here, run, and okay, we are done. We have our this raster file containing only two types of values, one for pine plantations and two for sources of seeds. Okay. The G's add this name to the rasterized field, to the rasterized file, but the original name file is this one, this target, which is the name that we gave to it. So I'm going to rename this because I really prefer. Okay. Now let's go to the next step. The next step is the number 5, and this is the process that we use to calculate the distance between each pine plantation at its closer oak forest. So the GIS will calculate the distance between each pixel labeled with 1 to its closest pixel labeled with number 2. Okay, makes sense. In order to do that, we will use this process that is already described here, the step number 5. We need a process, a tool called proximity raster, and we will call it by clicking process and typing here proximity. And this is the one that we are going to use, proximity raster distance. We open the tool. Let's open the tool, and then let's go for the input layer is this layer. The map number is the 1, and here we must type here the pixel values that will be considered as target pixels. In our case, this value is the number 2. Because the sources are the seed sources. So let's type here number 2. The distance units is georeferences coordinates, and we will leave these fields empty, and we just need to type the name of the output file, which is distancia1.tif. I'm going to copy this because I'm very lazy today, and I'm going to type. I need to browse to the folder. This is the folder, so just paste here. This is correct. Save, and then run. Okay, we already have the proximity map. We can add some fancy colors here using this palette, for example, magma palette. And well, this is our proximity map, but the problem is that our proximity map is covering all the area, and we only need the values of distance for our pine plantations. So we need to clip somehow the proximity map, which is called, we need to clip this layer with this one, with the pine plantations. I'm going to rename this because I don't like the name that this guy is giving to the layer. So I'm going to, I'm going to paste the name Distancia1. This is the real name for the file, And now let's go for the next step, which is the step 6. This step 6 involves the clipping of the distance layer with the distribution of pine plantation. But we are going to do that using a very simple mathematical process, which is multiplying raster. Because if we multiply any of these pixels occupied by pine plantations by any value, we will have that value, since all these pixels have number 1 as the values. And if we multiply any pixel containing with no pines by any other value, we will obtain 0, since these values are labeled, these pixels are labeled with 0. So we are going to do that using the Raster Calculator, and we will multiply pine plantations by distancia. And we will have a layer called, let me copy the name, I don't remember the name of the file. The name is distnat. Good. Let's browse again to the folder that we are working on, and we will paste the file name, and we are ready. And this is our new file is called distnat, as we said, and it is the same distance map but with the extension of pine plantations. Let's add some color here. Again, I'm going to use this palette now, and it is very easy to see how. I'm going to add some transparency here, and now I can see how I'm going to see this map as well. These white areas are considered seeds or sources of seeds, and these red areas are our pine plantations. And let's see how the farther we are from a seed sources, the higher is the distance. This distance, oops, sorry. If I click this pixel, which is very close to the source, I am going to obtain number 100. But if I click a little farther, I will have 300 meters, 600 meters, and 700 meters and 80. So this NAT is appropriate for our objectives. Okay, let's go to the next step. The next step is the number 7, and this is a very important step because we are going to translate the map of distance into a map of suitability regarding distance. As I already mentioned at the beginning of the session, we will consider that the closer the pine to a seed sources, the better, the more suitable for our objectives, because the closer it is, the higher the likelihood, the probability of obtaining seeds from these seed sources. But so we have, in order to have a suitability map from this one, from the distance map, we have to invert somehow the legend. So the suitability will be expressed from 0, which means no suitability, to 1, which means higher suitability. So the point here is that the pixels labeled with 100 will have a suitability of 1, the highest one, and the pixels labeled with this distance, 7,300 meters, should have a very low suitability, very close to 0. So in order to do that, we need to create a linear function to translate the distances into suitability. Okay, this process is described in this step 7, and it is also described here in this text. You can translate easily this text using Google Translator. But at the end, what we will do is to I'm going to zoom in a little bit. We are going to compute a linear equation to translate the legend of our variable, in this case distance, to the legend of our suitability map from 0 to 1. And once we work with this system of equations, we obtain this equation. So we need to transform our distance map in this. Distance map will be x, and the suitability map will be y. Okay. So we need to know the minimum value of our distance raster as well as the maximum value of our distance raster. All this information is described here. This is the equation. This is the maximum. This is the maximum value of our distance raster, and the minimum one is 100. So I'm going to calculate this function. I will copy it. And I have to go to the Raster Calculator. Excuse me. And I have to paste this here, and this equation is translating our our distance map into another layer containing the suitability of the landscape under the point of view of the distance between pine plantations and seed sources. I only need to create the file. I'm sorry, I don't remember the name of the file. The name of the file should be this aptdistancia.tif. I'm going to copy the file, the name, and I will paste it here, and we are almost done. Okay, please don't forget to select the layer extent. The layer extent will be the extent of this layer. So we click here and we click here in order to copy the extent here. And don't forget to add the reference system will be this one, 23030. Okay, ready to click OK. And now we have another layer containing values from 0 to 1. And let's add some color again, some transparency, some colors here. And now, excuse me, the suitability of this map should decrease from the closest areas to the farthest ones. So if we click here, I should obtain number 1. And if I click here, I should obtain a lower value. Okay, so this is working, guys. Great. Let's go for the next step. We are now here. We have created this layer. So we are at the end of a thread. We have already accomplished all this part of the workflow. We are working very fast. And now we are going to put a focus in the remaining variables, the density of the pine plantations, as well as the potential soil humidity. We will work now with step number 8. This part of the workflow involves the I mean, you don't need to do that. I already did that for you. So we will work with this file, and we will create the suitability map for this layer. And this is very easy to do because this layer, the tree density cover, it's here. It is already expressed in percentage from 0 to 100. And we already said that the higher the density, the higher the suitability of the map, because we need to do this clear cutting, this reduction of the intraspecific competition in forests that are very dense. So we need in order to translate this legend into a suitability map, it is very easy. We only need to divide this layer by 100, and we will have a layer describing the vegetation and describing the suitability from 0 to 1. It is very easy. Just go to Raster Calculator and TDC divided by 100. The output layer, let me check the name. The output layer is called apt densidad. It is also here, apt densidad. I'm going to copy again. And paste, save. Let's use this. Okay, and go for it. And that's all. Apt densidad is the suitability map regarding density, tree cover density. So we are now done with the step number 8, and we are ready to go for the step number 9, which involves CTI pines. Is the layer describing the compound topographic index. I already explained this. And we need to translate this layer into a suitability map using an inverse linear equation, as you can see here. And the function is described here in the step number 9. It's actually the same equation that we used previously in the layer called distance, but although the shape of the equation is the same, the parameters are different because the minimum value of the layer and the maximum value are different. These are the values that we need to know. I'm just going to copy that to the clipboard, and just a thing I forgot to let you know how to copy and paste the minimum and maximum values of each layer. You only have to click here and go to the tab called information, and here is the maximum value of the layer, and here is the minimum. Okay, sorry, this is the minimum. Okay. I already have the equation in the clipboard, so I just have to go to Raster Calculator and paste this equation here. And I need to give it a name. I don't remember the name, as always. The name is called apt CTI. I copy that to the clipboard, and again I browse to the folder, paste, and we are almost done. Select the layer extent, and we are ready. Oops, it seems to be wrong because we cannot see anything. It seems to be an empty layer. Yeah, but this is a minor problem. If you can see here, the minimum value is really low, and the maximum value is really close to 1, and the maximum value is really close to 0, but they are very extreme numbers. I'm going to solve this problem by clicking here symbology, and I will put the minimum value will be 0 and the maximum value will be 1. I'm not going. This process does not change the values of the raster. It only changes the values that the software used to draw the colors. So it's just a question. It's just an issue of representation. The minimum value is again 0 and 1. Okay. And oops, something was wrong, sorry, maybe I did a mistake. I'm going to repeat. I will remove this layer and let's go to the raster calculator again, and I paste I will copy the equation again here. Okay, this is a mistake. Pay attention to this. This is the name of the file according to the guideline. Okay, but the real name of the file is this one, is CTI Pines and this number. So what has happened earlier is that the system has not recognized this layer. So I need to add 23030 here, and it will work now. Okay. When you do that, you won't have this problem, because I will add this name here, so this won't be a problem for you. Okay. This is the name. This is the name. I'm going to overwrite the old file to replace it. Okay, and now it's working. Here it is. Okay. Yeah, this is almost 0. Classify, please. And okay, we are done. This is our suitability map regarding potential humidity in the soil. And well, my dear, we are almost done here. This is step number 9, and now let's zoom out to see a wider view. And now we have this layer, this one, and this one. So we are all set to integrate, to aggregate all those layers, and to create a map showing the suitability of the landscape to host these managerial activities called thinning, clear cutting. So we are going to the step number 10. If you want to learn a little bit on this technique, you can click here to download a PDF file describing it. It's a very easy to understand technique called multi-criteria evaluation that involves the integrations of the layer by summing them after multiplication by a weight. So we will add a weight to each layer, meaning the importance of each layer under the point of view of our objective. And according to each layer, according to that weight, the result will represent the importance of the layers. In our case, we can consider that the density of the pine plantations is the most important layer, because it is the point, the variable where the intraspecific competition is working, and the rest of the layer, the remaining layers will have a lower weight in our process. So the only thing that we need to know is to create the list of weights. The step number 10. We will consider that the density will have this weight. The humidity of the soil will have this one, and the distance to seed sources will have this one. All the weights must sum 1, because it's a sort of weighted average, what we are going to do. And once we define the weights, we just have to multiply each layer by its weight, and then sum all of them. So I'm going to copy this equation to the clipboard, and then I will go to the raster calculator, and I have just to paste the equation, and again I will define the name of the file. The obtained file will be called aptfinal.tif. And we are ready. Again, don't forget to do that. Okay. I think I did the same mistake. I didn't pay attention to the. No, yeah, this is wrong, because I didn't pay attention to the to the names, and some of them seem to be wrong. Let's check it. Apt densidad, apt distancia, apt CTI. Let's check here. Apt densidad is here. Apt CTI. Okay, it's here. And apt distancia, it's here as well. Let me check again. I'm sorry. Oh, it works. I'm sorry. I thought I did a mistake, but I didn't. So it seems that our layer is working properly somehow. No, it's not. Sorry, let me check again what's going on here. This raster seems to be empty. Well, so I did something wrong. Yeah, it's empty, so okay. Okay, let's check again what's going on here. Let's check the input layer for this final step is, I'm going to delete one. The input layers are apt densidad, which is working, okay. Apt CTI, which is working, okay. And the other one is apt distancia. I'm going to put it here. And apt distancia is working. So these are the three layers that we're going to operate with in the last step. Oh yeah, maybe the problem is, yeah. Here, it seems to be here a sort of blank area. Maybe that's the problem. Let's rename this layer. Okay. What a stupid mistake. Okay, let's go to raster calculator again, and we can paste the equation here. Okay, I think it's going to work now. I'm sorry, my apologies for the mess. But well, this and the name is apt final.tif. Yeah, replace it, please. Okay, and here it is. Yeah, this is the final, our final layer. This is our result. And let's put some color on it again. I'm going to use this quantile thing, and let's add some transparency, and let's add the aerial photography. And now the really the interesting thing is that our result shows the suitability of each pixel regarding our objective. This means that the bluish pixels are more appropriate to host these thinning activities than the reddish ones. So if we want to clear cut the forest, if we have some money to do this job, we should do it here instead of here. Okay, and we should do it here instead of here, for example. So this is a very nice result, a very interesting one. You can also go for this other thread, which is represented in blue here. It's not mandatory. I'm not going to do it because it is a bit more complicated and well. But just if you want to do it, just have a look to that. Follow this step number 13 and oops, this is a mistake. This is not 13. Well, I will solve it later. I was saying that you can go through this thread, this blue thread as well. And we are here now in step number 11, and we have obtaining this result. And our last step involves the reclassification of this raster, because we don't really need all those pixels with a very slow suitability value. I'm sorry, not slow, with a very slow suitability value. So we are going to consider that all pixels that have a suitability above a certain number will be suitable, and the rest will be not suitable. So I'm going to split this legend into only two classes. One will be 0 from, for example, from 0 to 0.8, and from 0.8 to 9 to 1. Sorry, we will have a suitability value of 1. This is described here in the step number 12. Yeah, step number 12. And we will do that by a process called reclassify by table, which is very, you're going to find it here, reclassify by table. And the raster layer is apt final, and the classification table it's here. We only have to add some rows. Let me copy the values. It's from 0 to 0.1.8, from 0 to 0.8 in the old layer, in this layer, as to all those pixels from 0 to 0.8 at the value 8. I'm sorry, 0. And from 0.8 to 1, I want you to add the value number 1. Okay. And then let me check that we are set. Okay. Okay, and the name of the file, the obtained file, is that one. I have already pasted to the clipboard. We save to file. This is the name, the folder. Okay, and run. And this is my new raster file containing white pines, white pixels are considered as suitable, and black ones are considered as non-suitable under the point of view of our objective. If you want to be more restrictive in this thresholding process, you can repeat the reclassification by increasing this value. For example, you can put here 9 instead of 8, and this will imply that the amount of pixels labeled as 1 will be lower. Okay. Well, and I think we are done. We are already here in the step number 12, and let's zoom out a little bit. We have done all this workflow. The only steps that we have not done is those labeled in blue, because we don't really, this is not really that important for you. Okay, well, thank you for listening. See you.